If you look at example 80.3, we got multiplication and division of scientific notation numbers. So, first thing I want to do is convert every one of them to good scientific notation. I'm going to pick on people. Let's start off with Mitchell, the blue one.
7 times 10 to the negative 27.
And let's move on to Preston. Let's go with the black one.
It'd be 4 times 10 to the 9.
Perfect. And let's go with Parker with the green one.
4.4 times 10 to the 4. Negative 4.
That is correct, but we want that to be 4, not
Negative
0.4.
fifth,
Right, very good. So instead of 0.4 times 10 to the negative 4th, we're going to go 4 times 10 to the negative 5th.
Sorry.
That's okay. Yeah, both are correct, but this is good scientific notation where the 0.4 was not. Okay, and then let's go with Ryder, 7 million.
I'm blind, but okay.
It's 7 followed by 6 zeros.
7.0, I guess.
Uh-huh.
Times 10 to 6 or 7 power. I don't know.
We'll go 6. All right. I have difficulty seeing, but yeah, 6 zeros. So we're decimal points here. 1, 2, 3, 4, 5, 6 spaces left to get where we belong. All right. So everything's now in good scientific notation. We're ready to go. Next thing we want to do after we get everything converted to good scientific notation is we want to multiply the top times the top and the bottom times the bottom. So Amber, give me 7 times 10 to the negative 27 times 4 times 10 to the 9th. What do you get?
28 times 10 to the negative 18.
Perfect. All right. So the abscissa of 7 times the abscissa of 4 gives me the new abscissa of 28. And the power of 10 added to the power of 10, since we're multiplying the powers of 10, we're going to add these. Negative 27 plus 9 makes negative 18. Subtract because the signs are different. Negative because 27 is bigger. Let's go with Kim. What about 4 times 10 to the negative 5th times 7 times 10 to the 6th?
28 times 10 to the first.
Yes. 28 times 10 to the first. Same deal. We have abscissa of 4 times abscissa of 7. 4 times 7 makes 28. Power of 10 plus power of 10. Negative 5 plus 6. Subtraction because the signs are different. Positive because 6 is bigger than 5. All right. Now, at this point, once we get the top answer and the bottom answer completely evaluated, last step is to divide. And again, these numbers aren't currently in good scientific notation, right? But again, the whole purpose of scientific notation is to make life easier. Does anybody see a problem dividing 28 by 28?
1.
That's easy, right? If it wasn't easy, do some modifications. But if it's easy, go ahead and go with it. And again, the power of 10, this is where people tend to mess up. I recommend every single time, top power as is, subtracted by bottom power as is, so you can actually see it with your eyes what you're supposed to do. What should I do, add or subtract?
Add.
Very good, add. So negative 19. 1 times 10 to the negative 19 is the correct response to that problem. By changing all these really unpleasant looking numbers into scientific notation, we had single digit multiplication and simple addition and subtraction, a pretty easy division, and a pretty easy, in this case, end up being addition. So the whole idea of scientific notation is to take things that do look pretty unpleasant, change it into some form that's easier to deal with, so the math's much easier to do.